Okay, with inferences about means, we are ready to talk about doing a hypothesis test. So with the hypothesis test, again, we need to meet those conditions that we specified in the previous video. And then we're going to run, notice this is exactly the same formula as for the Z. Okay, we're just using different symbols, but it's the exact same formula. We do have to be aware that we're on a different value, so the degrees of freedom matter. Okay. But otherwise, our hypothesis test is exactly as we ran with the Z's scores. And we can either do two-tailed or one-tailed, just like we did with the Z. So notice these are set up exactly like the hypotheses for the Z. Let's run through an example. I want to test the claim for that the population of statistic final exams, that the mean score is 75, when my sample data is n equals 16, my sample mean is 77, and my sample standard deviation is 15. We want to test at the 0.05 significance level. So my conditions, remember, are that it's random, it's 10%, and it is nearly normal. Okay. So for the randomization, that's not specified. So we'd have to say this only works if the data was collected randomly, right? 10% means less than 10% of the population. 16 is certainly less than 10% of all statistics students, so that one's met. And then nearly normal, I can't test for normality when I'm given summary data. So again, we have to specify this only works if this data comes from a normal population. And for test scores, that generally would be a normal population. So we're okay there. We're going to go ahead and proceed. So our null hypothesis then is that the population is equal to 75, and our alternative hypothesis, well, we're not told that we think that it's lower or higher, so we're going to do a two-tailed test. So we want, remember, this is going to be our negative critical T to our positive critical T. This is going to be our fail to reject region, and over here is our reject and our reject. So the area that we're looking for, since it's alpha equals 0.05, this is half of that, so 0.025. So if I'm doing the inverse T value to get the critical T, I'm going to use the 0.025. We're going to use the chart here. My N is 16, so let's go to the chart. I'm doing a two-tailed 0.05 with 15 degrees of freedom. 2.131 is my critical T. So let's go back here. So 2.131. So this is negative 2.131 to positive 2.131. That defines my fail to reject, reject region, reject. Okay, now we're going to now need to get the test statistic to compare to that critical T. So we can either use the formula that we have right here and calculate it by hand like we did in the previous example, or on your calculator, you're going to hit the stat key, you're going to go to tests, and you're going to go to T test. And plug in these summary statistics. If you do that, your calculator should tell you that the T value is about 0.533, and the P value that goes with that should be about 0.6016. Okay, so 0.533 is over here. So I'm in the fail to reject region. Or I'm comparing the P to the alpha. The P is bigger than the alpha, so I fail to reject. Either way, we fail to reject the null hypothesis. So what does that mean here? That means we do not have evidence to support the claim that the mean differs from 75. In other words, our sample data is in keeping with the idea that the mean score is equal to 75. All right, guys, that should help you through hypothesis testing.